Okay, now we are going to talk about trig identities. But before we start talking about identities, I want you to go ahead and solve this equation. 3 over 2x minus 4 is equal to minus 5 over 4x plus 7. So go ahead and try solve this one for x. Okay, to solve this one, as you remember from grade 9, I'm going to get rid of the denominators. I can multiply everything by 4 to get rid of the denominator. So I'm going to multiply this guy by 4, this guy by 4, this guy by 4, and this guy by 4. 4 over 2 is going to give me 2. 2 times 3x is going to give me 6x. 4 times negative 4 gives me negative 16. 4 over 4 gives me 1, so I get negative 5x. And 7 times 4 gives me 28. I'm going to move negative 5 to the left and negative 16 to the right. I get 6x plus 5x is 11x is equal to 28 plus 16 is 44. So I get x is equal to 4. Now, this, as you remember, is called an equation, okay? And the solution to this equation is x equal to 4. If I say the x equal to 5, is it the solution to this equation? Obviously no. There is only one solution, x equal to 5. This is why we call this one an equation. Now, what do you call an identity? Identity is an equation like this one, which is true for any value of the unknown. Probably you haven't seen it in your life, identity. How it can be an equation that is true for any value for the variable. I give you one example. For instance, I give you the following. Sine squared x plus cos squared x is equal to 1. This is an equation in terms of variable x, which is unknown. Use your calculator and tell me what is sine squared 30 plus cos squared 30. Just add them up. What do you get? Just do it. I mean, do it on the calculator. Do not assume that it has to be 1. Do it and see the result. Sine squared 30 plus cos squared 30. What do you get? You get 1, right? Now try sine squared 15 plus cos squared 15. What do you get? What do you get? Sine squared 15 plus cos squared 15. I'm not saying sine 15 squared. I'm saying sine squared 15 plus cos squared 15. 1. Okay? It doesn't matter what the x value is. This identity, this equation, which we call identity, is always true. This is what we're going to talk about today, identities. Okay? So some relations in trig are always true, like sine squared plus cos squared is equal to 1. No matter what the angle is always equal to 1, which we are going to go and prove it. And you can see, how simple the proof is. These are called identities. These relations we call identities. Now, there are some basic identities that it's given. You accept it. Although, still we can prove it, and we are going to prove one of them today. But in any test later on, when you have to prove an identity, there are some identities which are the base. Everybody accepts that they are true. And these are, the first three are given here. One is called Pythagorean identity, which is sine squared plus cos squared is equal to 1. Okay? That's the first identity. The second identity, the quotient identity, says that sine over cos is equal to tan, which you already know. The next one is reciprocal identity, which defines the cosecant, secant, and cot of an angle, cotangent of the angle. So these last two you already knew before, but we are using them as an identity here. But the first one is the one which is new to you. Sine squared plus cos squared is always 1. Okay, let's see how we can prove Pythagorean identity. Very simple. If I have a circle of radius r, okay, and a point on the circle, let's say the point is xy, remember that this here represents x, and this one represents y. Now, from the section 4.1, we said that the sine of any angle is the y coordinate divided by the radius. So I can write that sine of theta is equal to y over r, and the cos of theta is x over r. Now, if you look at this triangle, this is a right triangle, so I can write the Pythagorean theorem here. I can write that x squared plus y squared is equal to r squared. So x from here is r cos theta, y here is r sine theta, so I can write x squared is r squared cos squared theta plus y squared is r squared sine squared theta is equal to r squared. X squared plus y squared is equal to r squared. Now I can cancel r squared out, and I get cos squared theta plus sine squared theta is going to be equal to 1. This is probably one of the most important identity you will see. You will use this one left and right in every identity that you want to prove. So remember this one. Now this identity can be written in different ways. I can write that sine squared theta is 1 minus cos squared theta, or cos squared theta is 1 minus sine squared theta, which all comes down to sine squared plus cos squared is equal to 1. Okay, now let's say I give you an identity like this one that you're not going to see in this course. You will see it in advanced function. That something like, prove that sine 2 theta is equal to 2 sine theta cos theta. Now, just to make sure you understand this one, let's say theta is 15 degrees. What is on the left? Sine of what? So if theta is 15, sine 2 theta is sine of 30. So use your calculator and tell me, is sine 30 equal to 2 sine 15 times cos 15? Now, to prove an identity like this one, this is the way that we usually do. The equal sign has two sides, left and right. Always start with the side which has the most complicated expression. Okay? And then start simplifying that side as much as you can. If you get to a point that the left and right are equal, that's it. Then you prove the identity holds. There are cases that you get to a point that you can't simplify the right-hand side or left-hand side. Now go back to either right or left, the one that you haven't touched, and start simplifying the other side until you get to a point that both sides are equal. Then you are done. You prove the identity. So the whole idea of proving an identity is to simplify either left or right until you get to a point that it is equal to the opposite side. The process is very simple. It's not hard. Okay, now let's see how we can prove tan squared plus 1 is secant squared theta. I'm going to start with the most complicated one, which is the left one. Doesn't mean that you have to start from left, but usually you start with the one which is a little bit more complicated. Now, instead of tan squared, I'm going to write the tan squared. And remember, tan is sine over cos. So I can write this one as sine squared theta over cos squared theta plus 1. Everybody okay? Now I'm going to take the common denominator here. Remember, the denominator here is 1. The common denominator is cos squared theta. Now I'm going to divide cos squared theta, which is here, by every denominator and multiply by numerator. So from the first one, I get cos squared theta divided by cos squared theta gives me 1. Multiply sine squared theta, I get sine squared theta. Now cos squared theta divided by 1 gives me cos squared theta times 1 gives me plus cos squared theta. Everybody okay? Now I use the Pythagorean identity. What is sine squared plus cos squared? 1. So I can write this one as 1 over cos squared theta. But this one is really 1 over cos squared theta. 1 over cos theta squared, right? But what is 1 over cos? Secant squared theta. And we just proved the identity to be true. Now, the next example is to prove that 1 minus cos squared theta is sine theta, cos theta, tan theta. Again, it's your decision which side you want to simplify. Which one is more complicated? Is it left or is it right? You decide. So which one you decide? Which one do you do, left or right? Right, excellent. I would pick over right too, because I have so many functions here, sine, cos, and tan. And I can simplify some of them. So go ahead and simplify the right one. Okay, to prove the identity, I'm going to pick the right-hand side and simplify it. So I'm going to write tan theta as sine over cosine. So I'm going to write the right-hand side as sine theta times cos theta times sine theta over cos theta. Again, I'm using all the basic identities. I don't need to prove that tan is equal to sine over cos. Okay? That's the quotient, which we talked about it before. Now, cos theta cancels with cos theta. I get sine theta times sine theta, which is sine squared theta. Now, by Pythagorean theorem, Pythagorean identity, I know that sine squared plus cos squared is 1. So I can replace sine squared with 1 minus cos squared. And this proves the identity. Okay, next example. Prove that sine theta over 1 plus cos theta is equal to 1 minus cos theta over sine theta. Okay, the way that I'm going to solve it is that I'm going to multiply the left-hand side, the numerator and denominator, by 1 minus cos theta. So the left becomes sine theta times 1 minus cos theta divided by 1 plus cos theta times 1 minus cos theta. Everybody okay? I'm just multiplying numerator and denominator by the same number. Now, I can write the numerator the way that it was before. But what is 1 plus cos theta times 1 minus cos theta? A plus b times a minus b. It's a squared minus b squared. So 1 plus cos theta times 1 minus cos theta is 1 minus cos squared theta. Now, by Pythagorean identity, 1 minus cos squared theta is what? Sine squared theta. Excellent. So I get sine theta times 1 minus cos theta divided by sine squared theta. But now I can cancel out sine theta from numerator, and the denominator I get 1 minus cos theta divided by sine theta, which is the identity.